Hello everyone, today we are going to study that normally in heart parasympathetic control dominates over sympathetic control. However, the sympathetic control lasts longer and the effect of parasympathetic stimulation is short-lived. This is our scenario and why we are going to study a little bit about it. First of all, it has been observed that when the heart is completely denervated, it means that it is free of all the neural influences. That time it was observed that its heart rate was coming 110 times per minute, which is more than our general normal range, that is 60 to 100 times per minute. So this gives us an indication that in the neural influence, the parasympathetic system, which work is to decrease the heart rate by vagal stimulation, its effect is more than sympathetic influence. Now let's see the parasympathetic fiber. They originate from nucleus tractus solitarius, dorsal motor nucleus of vagus, and nucleus ambiguous. The parasympathetic fibers which have control over heart. So basically, and these fibers travel in vagus to supply the SA node. And and generally in the right vagus nerve and left vagus nerve. The right vagus nerve predominantly supply SA node and left vagus nerve predominantly supply AV node. What happens on vagal stimulation is that ACH is released at vagal nerve ending. And what does ACH acetylcholine, and what it does is suppress the SA node, which means decrease in heart rate. But this ACH acetylcholine, its hydrolyzing enzyme is acetylcholine esterase, and this acetylcholine esterase, its increased concentration is found in nodal tissues. Hence it has been observed that the single stimulation of vagus produces a short-lived effect on SA node, because this acetylcholine released will be degraded by this choline esterase. In fact, this action of choline esterase is so fast that it allows beat to beat control of SA node by vagus nerve. On the other hand, let's see sympathetic innervation of heart. In sympathetic innervation, the fibers supplying the pacemaker tissue originate from lower to cervical and upper 6th thoracic segment of spinal cord. What the sympathetic innervation does, it's promote the increase in heart rate, and it persists longer than parasympathetic effect. The reason is because in parasympathetic, the mediator released at nerve ending, the neurotransmitter was acetylcholine, and choline esterase was present, which was degrading it after its release. But in the case of sympathetic stimulation, the norepinephrine and epinephrine, which are catecholamines, are released at the nerve endings, and there is no such enzyme to degrade them. So generally what happens is that this norepinephrine is taken up by the nerve endings, by the sympathetic nerve endings, and then it's in the reabsorbed in the circulation, slowly reabsorbed in the circulation, instead of having a particular enzyme for degradation. And also one another point that can be added is that the norepinephrine mediates by this adenylyl cyclase system, which generally takes a larger time to exert its effect. Okay, so overall that is the reason that in ACH, when the ACH is released by vagal stimulation by parasympathetic system, then there is an enzyme called acetylcholine esterase which degrades it, and its higher concentration is present in nodal tissues. Hence the effect of parasympathetic stimulation is short-lived, and also hence this it is called beat to beat control of SA node by the vagus nerve. On the other hand, in the case of sympathetic innervation, for norepinephrine, there is no particular enzyme to degrade it. It's slowly absorbed in the circulation, and also it's mediated via adenylyl cyclase system, which takes larger time to exhibit its effect. Okay, the right vagus nerve supplies the SA node predominantly, and the left vagus supplies the AV node predominantly. This explains our statement. Anyways, bye. Thank you guys. Keep learning.